Welcome back to Wildcat Academy. Today we're going to be talking about exponential equations with base e. We're going to take a look at 4 examples today. The first one, we're going to have, you can see that we have a common base here. E to the 2x is equal to e to the x plus 9. We're going to use our common base method here. We can just set the exponents equal to one another. Again, just a reminder there that if you have b to the x is equal to b to the y, then the exponents would therefore have to be equal x is equal to y. So that's what we're going to use here. So we have 2x is equal to x plus 9, and then we'll subtract x on the left-hand side and the right-hand side, and we'll get x is equal to 9. And that will be our solution. All right, a little more interesting problem would be example number 2. And over here we have e to the x is equal to 6.7. Much more common example that you will run into working these problems. And we're going to have to use logarithms to solve this problem. So we will already have the base and exponent isolated on one side, condensed down. So we will just need to take the log base e of both sides. So I'm going to write that out just so you guys can see it. So take log base e of both sides. However, log base e is the natural log. So we really wouldn't, a mathematician really wouldn't write log base e. They would use the shorthand natural log of e to the x. And just remember that natural log is log base e. On the left-hand side, we have natural log of e to the x. And we can move that exponent off here and have natural log of e is equal to the natural log of 6.7. You don't have to show this step. You can just understand that the whole purpose of us taking log base e of e, that cancels out to be 1, or the answer of that is 1. And then we end up with x times 1, which is x. And we end up with the natural log of 6.7. So once again, I probably wouldn't write this step, the 2 steps with the arrows. It would just be step 1 here and then step 2. And so once we input the natural log of 6.7 into our calculator, we'll get 1.9021 as our solution. And that is a rounded solution, of course. Approximated. It just occurred to me that some people may not remember what the value of e is. So e is approximately 2.7183. It is a number that occurs throughout several areas of mathematics, but you can kind of think about it as being like pi, 3.14. It's an irrational number. We encounter it a lot, especially whenever we're studying exponential functions. But for right now, you can just think about e being 2.7183. And again, it is an irrational number, so it continues on, but we're going to shorten that down. In example 3, we're faced with an exponential function, base e. We have added 2. We have the coefficient 3 on the exponential term there. So we want to isolate that exponential term by subtracting 2 and dividing by 3. So you can think about this problem being as 3 times some variable x plus 2 is equal to 2012. And we will just be subtracting 2 and dividing by 3 in order to isolate this piece of the equation. So let's go ahead and get to that. So 3 times e to the 4x is equal to 2010 when we subtract 2 on both sides. And then we will divide by 3. So e to the 4x is equal to, so that's equal to 670. Then we will take, we want to cancel this base e, or move that exponent down so we can solve for x itself. So we will take the natural log of both sides, natural log of e to the 4x This gives us 4x is equal to the natural log of 670. I'll surely exactly why I put 4 in there. That will be 4x. And then we will divide by 4. So the natural log of 670 we will divide by 4. And it's always good to wait till the very last step to round. And we can type that into our calculator there. And x is equal to 1.6268. And again, this is an approximate value. Okay, so in example 4, very similar to example 3. Looks like having a little glitch there on the 2x minus 5. Let's go ahead and clear that up. That's 4 times e to the 2x minus 5 minus 10 is equal to 4,567. So again, we're going to add 10, divide by 4. We have a two-step process at the end once we break off the exponent equal to the natural log of a number over here on the right hand side. So we're going to add 10 and then we will divide by 4 will be our first steps. So 4 times e to the 2x minus 5 is equal to 4,577 when we add 10 to both sides. And then we will divide by 4. E to the 2x minus 5 is equal to 4,577 divided by 4. Don't be worried there. If you can put a decimal value, you can leave that as a fraction. It's really completely up to you. So now we'll go ahead and take the natural log of both sides. We'll get 2x minus 5. Go ahead and as we take the natural log of this side, we know it cancels the e, and we're just left with the exponent. And then we have natural log of 4,577 over 4. That's just going to be a decimal value. We'll worry about that in a minute when we put it in the calculator. And then we're going to take that value, we're going to add 5 and divide by 2 in our last steps. You can do all of that in the calculator, or some problems may ask you to go ahead and show that what you're typing in there. You know, the ACT is really good about asking these type of questions. So we'll end up with natural, well, if I can write the natural log of 4,577 divided by 4. We're going to add 5 to that, and then we're going to divide it by 2. So when we type this in the calculator, we end up with 6.0213. And again, that's an approximate value. All right. That kind of gives you a good base to solve any exponential function with base e. Remember that you're going to be taking log base e of both sides, which is abbreviated the natural log. So again, I think that's key to understanding how to solve these problems. So you're going to be taking the natural log of both sides, and then you'll see it represented that way. All right. Thanks for sticking around to the end of the video. If you like the video, you found it helpful, be sure to hit the like button, subscribe to the channel so you don't miss out any more videos from AutoCAD Academy, and look forward to seeing you next time.